Hey engineers, in this video we'll be talking about image understanding in Gemini, which is a feature that allows Gemini to understand the context of your provided image, allows you to identify objects in images, and even edit these images. For you to understand this video, you must have watched the file upload video, or you must have an understanding of how file upload works in Gemini. I've made a video that will put maybe year or year that covers this in depth. As usual, the code and the links to the repository is provided in the description. Please try this yourself. Don't just watch tutorials, don't just watch my videos, try it out yourself because that's the best way you would learn and this will stick. In the last video, we saw audio understanding with Gemini, where we gave Gemini a list of different audio tasks and we allowed it to basically understand the audio, to transcribe it, and to do different functionalities. And in this video, I'll be showing you how to do something similar, but with images. Welcome to Image Understanding with Gemini. Let's get into the video. If you've been following along the series, you will know that these two resources are very important for us. It is the Gemini Cookbook, where other developers have added their code samples of how they achieve different tasks, and also the Gemini API doc. Now for the outline, we'll be going through the setup, limitations, prompting techniques, object detection, also called bounding, segmentation, and I'll be explaining the two types of segmentation Gemini uses, semantic and instance, and we'll just have a quick recap and we'll go through conclusions. As usual, I've provided this notebook for you. Please take the code, try it out, and run it yourself. Before we get into the setup, the first thing we need to do is to make sure that the notebook has access to our Google Drive. And if you just click that link, you will see Connect Google Drive, and then you'll be able to connect a Google Drive folder to it. Another thing that you need to do is to provision a Gemini or Google API key. You can do this easily in the Google Notebook by provisioning one by clicking this Add Secret button, but I've already done this already, and make sure that you always grant the notebook access to this key. For setup, we'll be using Google's Gemini API client. We'll be using a couple of Python packages like the Datetime library, the NumPy array, the Pillow library, also known as Pil, and just some IO libraries that Python provides. And so let's run this. Now let's take a look at the limitations before we go deeply into the code. For image understanding with Gemini, Gemini only supports PNG files, JPEGs, WebP, that is iPhone compatible images, HEF, and as usual, for most of what you'll be doing in Gemini, there is an inline file limit of 20 megabytes, including the prompt to use in your text and also the image you upload. Rotated files are also not supported by Gemini, so ensure that whatever file you're trying to understand is correctly rotated in the format that Gemini accepts. You should also set your thinking budget to 0, and if you don't know what thinking budget is, make sure you go back and watch the first video in the series where we covered text generation, because Gemini by default ships with thinking mode, but setting a thinking budget of 0 ensures that Gemini does not use chain of thought in generation of the text. Another limitation you should be aware of is that Gemini currently only supports 3,600 file images per request. And if you're working with single line images, and if you're working with just a single image, ensure that the image is placed just after the text. And if you're working with single images, ensure that you place the text or the prompt just after the image in the request to Gemini. Also, I'm going to show you how to do segmentation in Gemini, but you should be aware that this is an experimental feature. Lastly, during my testing, I discovered that while Gemini excels at image understanding tasks, the harder the task is, the more difficult it is for Gemini to successfully provide correct output. So, single inline file. The way you work with an inline file in image understanding is the same way you do it in every other task that requires working with files in Gemini. I've provided this image that contains different flags from different continents in the world. And we're providing Gemini this image, and we're trying to ask it for it to generate an alternative text. So here we go. Gemini successfully generated an alternative text that says a grid of 24 national flags represented as round square icons in a light background, and it lists all the countries in the rows. And if we just go to the last row, Malaysia, Spain, Switzerland, Nigeria, Uganda, Portugal, Malaysia, Spain, Switzerland, Nigeria, Uganda, and Portugal. That is correct. More often than not, you'll be working with files that are larger than 20 megabytes, and so you must know how to upload files. I have covered how to upload files in a previous video. I will link it up somewhere here or here, but for the purpose of this tutorial, we will be using one of our popular images in this tutorial, the cat image that we've been working with, and we'll be uploading it to Gemini and prompting it for some understanding of the image. So I will just run this here, and we should see that it successfully generates an alternative text of the image provided. This is something I think that AI models really excel at, that I'm surprised a lot of social networks don't currently yet use, that is being able to automatically generate alternative text based on files uploaded by users of those platforms. And I really do hope that people catch up, because this will be very useful for people who are disabled or who require assistance or screen readers to interact with the web. As we can see, Gemini has successfully generated an alternative text for this cat image uploaded, and it says here a close-up shot of an orange and white cat grooming itself. The cat is lying down with his eyes gently closed in apparent contentment. Now, you've seen how to interact with Gemini through inline files, and you've also seen how to send upload files in its prompt. But there is also a way where you can combine both to get Gemini to generate successful responses for you, and that is what we'll be doing in the next section. So we'll be using our previously uploaded file and our previous inline file, and I pass it here and I say, what is the difference between these two images? As you can see, it successfully generates a response that these two images are completely different in every aspect. In terms of subject matter, image 1 features a single living animal, while image 2 displays a collection of 20 different national flags arranged in a grid position. And in the terms of the types, and it gives us the theme and the content, the number of elements, and also the background. As you can see, Gemini has successfully identified everything in these images, and it has also provided a very accurate description of the difference. In the previous section, we just scratched the surface with image understanding in Gemini, and in the next couple of chapters, I'll be showing you how to do powerful things such as object detection and segmentation. Object detection, also known as bounding, is the process or feature that allows models such as Gemini to detect objects within an image. These models produce coordinates relative to the image that scales between 0 to 1000, and these coordinates would then be scaled down to the dimensions of your images. These models produce coordinates that are relative to the image dimensions and scale between 0 to 1000. And these coordinates form a bounding box, which is why it's called bounding, that you then need to scale down to the size of your image. But enough of explanation, let's get straight into the code. Over here, I have copied a very useful util from the Google Colab notebook that helps us to plot the bounding boxes once Gemini has detected them. I will just run this here, and we'll be using the same flag image that we've been using and what we'll be doing here is basically we'll be telling Gemini to identify each of the flags here and to basically put a bounding box on each of them and label them. And so as you see here, the prompt says detect the 2D bounding boxes of the flag with label as country name, and we pass it the image, and we just basically specify a system instruction in terms of what the bounding box should look like. And we also specify safety settings. Safety settings is useful in case anyone basically wants to upload content that is not allowed. And we set the thinking budget to 0, and we just set the temperature. And if I run this, Gemini has produced successful coordinates for the flags in the images, and it produced a JSON of each of the coordinates with the labels of the country. But this is not really useful for us. What we want to do then is basically plot each of these coordinates on the image. And as you can see, we have United States of America, we have United Kingdom. I know you can see the text. That is something that I think one could easily fix, but we see it successfully labels China, Saudi Arabia, Germany, India, Australia, Russia, Brazil, Canada, France, Portugal, Nigeria, and so on and so forth. So that is bounding box in a nutshell. Let's give Gemini a harder task for it to identify the odd emoji out. Can you find where the odd emoji out is here? This is super difficult, and it took me a while to find it. If you successfully do this on the first try within 10 seconds, you are honestly cracked. But let me show you where the odd one out is, and let's see if Gemini can also identify this. This is the odd emoji out, this laughing emoji here, and it's completely different from all other emojis. But this is a task we want to see if Gemini can successfully do. Basically, we pass the same image and we tell it, show me the only emoji that is different from other emojis and tell me why it is different. Now let's see if Gemini can successfully identify this laughing emoji. And we see here that Gemini fails woefully to identify the laughing emoji. In fact, it actually returns 2 results and it says the only emoji that is different from other emojis is different because it has sweat drops on its forehead, while other emojis are simply smiling with closed eye. This is completely wrong, and it shows that the harder the task or the more complicated the images, Gemini seems to perform very poorly in identifying or understanding the image. But to show you that this is because of the difficulty of this task, I would give it a simpler one where it should be relatively easy for it to identify the emoji in this particular one out. And as you can see, the emoji that is different is this. Let's see if Gemini can successfully identify the different or the odd one out. Awesome. We see here that Gemini successfully identifies the odd emoji out and it correctly puts a bounding box around it. And it even tells us that the odd emoji out because it has both eyes open and a straight mouth, unlike the others which have one eye winking and their tongues sticking out. Correct. In this part of the video, we'll be looking at segmentation, and segmentation is completely different from bounding box. While bounding box puts a rectangular square around things that are completely related, segmentation allows us to have a pixel perfect tracing of objects in the images. Now think, for example, in this emoji example, while we successfully added a bounding box, it added a box around the emoji but also including the background of the emoji. But segmentation would allow us to trace the emoji pixel perfectly. Gemini Mini performs 2 types of segmentation: a semantic segmentation where it puts pixels based on a category. For example, think of an images of different trees, you provide it to Gemini for image understanding. Gemini could then segment those trees into a single category called trees. But in instance segmentation, what it does is that while it groups it into trees, it could then identify each of the individual categories in the parent category and label them specially. Take, for example, while it identifies that these are trees, it could go as far as identifying each of the characteristics of the tree and also trace them pixel perfectly. So let's get into the code and how to achieve segmentation in Gemini. This is another util that I've copied from the Google Colab notebook, and it's just some utilities that helps us to draw segmentation lines on top of the image. And if I just run this here, and you see the prompt here says, give me a segmentation marks for countries in Africa and Asia. Again, I am tasking and challenging Gemini here. Fine, that is an image of flags and it can identify those flags, but I'm also telling you that I want you to locate only flags within Africa and Asia continent. And I want the result to be output as a list of JSON where each entry contains the 2D bounded box in the key box 2D and the segmentation marks in key mask and the text in label key label. Let me just run this and you see it, and this is the result of my previous run. And as you can see, it successfully identifies countries within Africa and Asia, and it successfully labels it and traces it pixel perfectly. Let's compare it to our previous bounding box example where it also correctly traces it in bounding box, but you see that the label here is quite problematic. But because of pixel perfect tracing, where we use segmentation for this, it can even identify and place the label correctly at the top of the image. And it says here China, Saudi Arabia, India, United Arab Emirates, South Africa, Nigeria. For some reason, I'm sure Uganda is there, but we can't say it, and Malaysia.